Welcome everyone to another interesting problem, and this particular problem will be the continuation or related to the reverse linked list part 1 problem. So let's try to understand what is the problem statement. So you will be given a linked list. As you can see, you are given a linked list. Also you are given, so in linked list one more thing is there is head. Okay, and also you are given two integer values. One is left and right. That's also in one index thing. So left equal to 2, that does mean 1 2. It represents the second node. And left equal to 4 means 3 4. It represents the fourth node. What you have to do, you have to take the left as the beginning node and the right as the ending node, and you have to return that particular portion of the linked list as reversed. For example, the 4 will goes here and 2 will goes here. That is sufficient to return it. How can we do that? It is not as straightforward as reversing the entire linked list. In reversing the entire linked list, it was just a matter of like reversing the direction of the pointers. Here it is not like that. It's slightly different. So how can we do that? So there are few steps we could follow to reverse linked list in between. So what we can do is that first we need to locate. So I'm going to tell few steps. This would be ideal to follow. First, locate the left minus 1 node. Basically that means we have to locate, in this our example, this node. We have to locate this node, and then we can assign, let's give that locating this thing to previous. This is the pointer name. And step 2, assign current as previous dot next. So what we are going to do is that from this particular example, somehow if we are able to locate this as previous, then the current would be initially would be previous dot next. Then what we need to do, we can use another pointer. Step 3, assign another pointer. This particular, from here on we have to do, like from here on, do this action, right minus left time. This has to be done. Then what we can do, we can use another pointer called to move. That is nothing but current dot next. In this example, this would be the to move. And what we can do, initially we can take this to move node, bring it down. For example, I will tell you, if this was 1 2, let's bring it down, the 3, then 4, and it goes to 5. What we can do, this is the to move. Right now this is to move. What we can do from here, like the current dot next, current is nothing but here. The current dot next, let's map it to move dot next. Okay, this will become like this. This pointer will goes down. And to move dot next, that is this pointer, let's assign to previous dot next. That's nothing but here. And previous dot next would be assigned to here. So let's write it very clearly. This can create confusion, so let's write it very clearly. So let me copy this particular example. I hope you have understood so far how we are assigned these pointers. We have not explained the step 1, how to locate left minus 1 node, but that will be explained while we coding. But let's understand how we are going to move forward. Okay, this is the example. So what we are going to do this particular step, do it right minus left times. What we are going to do, to move would be assigned as current dot next. Okay, then what we are going to do, if this is the case, 1 2 3 4 5. There is a reason why I wrote the 3 slightly below from the line. What we are going to do next, let me mark the pointer also. This is current, this is previous, this is to move. Next step would be current dot next. Current dot next would be assigned as to move dot next. That is nothing but this particular pointer would be now going towards here, to move dot next. So let's erase it and mark it like this. Then what is next going to happen? To move dot next. To move dot next would be going to previous dot next. So this is to move dot next. This would be going towards previous dot next, that is here. So let's erase it and mark it very well. This would be going towards here. And previous dot next. Previous dot next. Right now it's going towards current. It should go to move. So let's erase this pointer and it will go towards here. Then let's rearrange and write it. So it would be like that. This is 1, this is nothing but previous, now point towards 3, this is nothing but to move. To move is now pointing towards 2, that is nothing but current. This point to 4 and then 5. So what is happened here? This 3 has been pushed in between previous and current. Basically whatever be the current dot next, that is to move, that particular node by following these things will be moved or pushed in between the previous and current. Basically it will be moved to previous dot next. This location will be moved. So once this is done, here you can see the current and previous pointer are static. It is not getting updated. Only to move, this is node under consideration. That is the only thing which you are going to update in this particular iteration. Do it until right minus left times. Here right is 4, left is 2, it would be 2. So basically you have to do it 2 times. So once we, in the first step we got something like this, so we are going to do it again. Here in this particular step, in the next step, to move became current dot next. That is nothing but this to move, this pointer would be taken to here. Okay, so we can just erase this pointer. To move became this, and whatever we have did here, this kind of swapping will happen, right? What in this case, what we can do, take this 4 slightly below and this pointer will go towards 5, and whatever the pointer coming from to move dot next, this pointer right now will point to previous dot next. That's nothing but here, and previous dot next will go to move. Basically this 4 will be pushed to a location, that is previous dot next, and before pushing to this location, whatever be the pointer coming towards it, and whatever be the pointer going towards it, these two things will be appropriately arranged. Whatever be is coming towards it will now go towards its next. Whatever the pointer going from it will be point towards previous dot next, and previous dot next pointer will be coming towards it. So like that this pushing happens. So in the next step it would be 1 4 3 2 5. Slightly messy, but 1 4 3 2 5. This is nothing but 1 4 3 2 5. This is nothing but our result. So let's organize it, and we need to explain what is step number 1, how to arrive at the previous pointer, because basically there are 3 pointers involved in the example: previous, current. This we are not going to change at all. And where to consider the to move variable depends on always on current dot next, and then basically we push it here initially, then after that it will remaining things will go here, then again this will be to move, we again push it here, like that it would be reversed. So let's try to code it, and there is one small edge case also, that also we will discuss. So let's try to code it. So this is the class solution and what is the method of the class? Reverse between, let's start with the name. Arguments, let's write for ourselves. Head is given, which is nothing but optional list node. Then left is given, which is nothing but an integer. Right is given, which is nothing but another integer, and at the end we just need to return the starting point of the linked list. And few of the things which I have not explained, I will explain here while doing. So there is an edge case. If the linked list is empty or left equal to right, that means you don't need to like reverse anything. In that case, just simply return head. So this head is straightforward. If not head, that means linked list is empty, or left equal to right. In that condition, just return head. And I need a dummy node. I will explain why we need a dummy node. List node, let the value be 0. It doesn't matter. Then I am going to connect the dummy node to the head. Why I am using a dummy node here? At the end, we just need to return a node, that starting node. What if the left was in the problem statement given as 1, then this node would have been a part of reversal. In that case, the head pointer itself would be moving from its starting location to some other cases. So that would be a problematic thing. So in that case, it's always, if you want to return the starting point, it's always a good practice that let's create a dummy node here and connect it to the beginning node. So we can connect something like dummy.next equals head. So at the end, it doesn't matter wherever the pointer head belongs to after the reversal. We just need the starting point, that is nothing but dummy.next. So this is the clever strategy we can use at the end to return. Okay, now let's start from, there are 3 pointers as we mentioned. Previous is nothing but this particular, in this particular example, the previous is nothing but a pointer. Okay, locate that pointer which is left minus n node. If this is the node which is starting, previous pointer would be just before that. So how to find that previous node? Initially, let's fix to dummy, and with a iteration we will be going to arrive at that location. For that we can retrieve for dash in range of left minus 1 previous equals previous dot next. In the problem, in the example, left was 2, 2 minus 1 equal to 1. So it will iterate one time. So in this example also you can see initially it's in dummy D. So at one iteration it will jump from dummy node to the first node, that would be previous. So it's already there where we wanted. Okay, so once we located the previous, we just need to now assign the current node. Current equal to previous dot next. So that's it. From here on, it's all the manipulation which we discussed. We just need to locate previous and current. We are not going to change these pointers. These pointers will stay where it is. And the pointer, assigning the pointer to move, will always depends on current dot next. And where should we move this particular node? That would be previous dot next. That's the only logic behind that. Remaining, it's all about cutting down the pointers and assigning it appropriately using whatever we have explained. So we have located the previous pointer and the current pointer. Now let's do the task which we have explained for right minus left times. For dash in range of right minus left. Okay, now let's decide what is to move. To move is nothing but current dot next. Okay, if you want some like you don't have to by heart anything, so you can just remember this thing. Okay, this 4 node is enough. This is previous. Okay, this is current. This is to move. Okay, initially it's connected like this. What we need to do, we need to like cut down current dot next. Okay, current dot next to move dot next. So basically what's going to happen, this particular pointer will now go here, then to move dot next. Okay, to move dot next will go to previous dot next. Basically this particular pointer which I am erasing now will go to here, and previous dot next will go to move. So this particular pointer which I am erasing now will go to move. So at the end what is going to happen? Okay, let's rearrange and write it. So basically the to move previous would point to move now, then followed by the current, then whatever the remaining element. And in next iteration this to move would be someone at current dot next. This will become to move, and again whatever we just cut down the pointers, and this particular node will move here. Okay, that will keep on happening at right minus left times. That's the logic of swapping in between. So once this is done, we just need to return, as I said, return dummy dot next, because what if the head pointer itself has moved. So in order to pass all the test cases, this is the ideal scenario. Okay, what is the time complexity? We are just iterating it to once. We are not like doing a back-to-back for loops or anything. So straightforwardly, intuitively also you can say the time complexity is order of n, space complexity is order of 1. I hope you understood this particular problem of reverse linked list part 2, basically reverse in between the linked list. So it's a visually one of the very challenging problem. I hope you understood and try to do a pen and paper explanation, so that would be much more appealing and much more grasping in the mind. I hope you understood, and thank you for listening.